continue with from the previous sessions, we have seen how for a language how to form an DFA, and you have seen also the transition tables. Okay, now we'll move on to how to program this particular part with the help of a Python, and we are going to use a package that is going to be Automata. So as I have already mentioned, we have to import the package automata.fa.dfa, import DFA, everything has to be in capital. So we are going to mention all the tuples here. The first tuple is going to be the states. So we have Q0, Q1 and Q2. So that state has been mentioned here. Then we have an input symbols that is going to be zeros and ones. So that has been mentioned here. Remember, states equal to, it has to be in curly braces, and each state it has to be mentioned in single quotes. As well as the input symbols also, it has to be mentioned in the single quotes. And input underscore symbols, these things will throw an error if you have mentioned it in a wrong way. The next one is we have to mention the transitions. Either you can see the diagram and you can mention the transitions, or you can see the table and you can put the transitions. Here we can see Q0, it is reading 0 and it's moving on to Q0 itself. So Q0, it's reading 0 and moving on to Q0. Q0 reading 1, it is moving on to Q1. So 1, Q1. Then Q1, it's reading 0 and it's moving on to Q0. So here you have Q0. And Q1, it's reading 1, it's moving on to Q2. So you have mentioned Q2. The next case is we have Q2, it's reading 0 and it's moving on to Q2 itself. Okay, and the next one is Q2 is reading 1, it is moving on to Q1. So all the transitions has been mentioned. You can also the diagram and you can mention the transitions also. The next one is you have to mention what is the initial state. The initial state is Q0, so that has been mentioned. And you have to mention the final state. The final state is Q1. The Q1 is the final state. Why they have mentioned this in a curly braces is, in some cases we can have more than one final state. If that is the case, we have to mention it with the help of a comma. Okay, the next one is we have formed the finite automata, deterministic finite automata. We have to check whether the input symbol has been read or not. So the input symbol, we can take any examples among this set of strings. We will take just 0 1. So 0 1, we are going to read it. So with the help of dfa dot read underscore input, it will be returning me as Q1. In the case of 0 1 1, what is happening is it is moving on to a non-accepting state. So obviously it is going to return me an error. Okay, then we want to see how the stepwise input transition is. So if that is the case, we have to mention the transition. So in that case, we are going to just take something which is not accepted, but it also will tell you what is the transitions is going to be. So 0 1 1, it's not going to move on to an accepting state, but you can see what is how it has been traveled. So if that is the case, what it is going to do, first is 0. So 0, it's moving on to Q0 itself. So Q0 to Q0. Q0 to Q0. Then it is moving on from Q0 to Q1. So from Q0, it is moving to Q1. From Q1, it is moving on to Q2. So that has been mentioned here. Then we can also define with the help of control statements if and else. If that is the case, we can use something called as accepts underscore inputs. Okay, if it is an input that is accepted, we can just put it as accepted. If it is not accepted, it is going to be moved telling me as rejected. So you are going to read something called as 0 1. It is going to be an accepted one. So I'm just putting 0 0 1. So it is moving on to an accepted state. If it is not going to read this one, it has to be moved on to a rejected state. So obviously we have mentioned as 0 1, so it will be moving on to accepted. If we have mentioned as 0 1 1, it will be giving me an reply as rejected. Okay, this has been implemented with the help of Anaconda Jupyter. So I have mentioned everything. You can see for this one, it is throwing me an error. And for this case, it will be giving me the values. Okay, the next one is some of the examples you can also see. Here we have ab to the power n. N can be any number. So since we have put it as star, you have to remember you should have epsilon, that has been missing here. Okay, so what you have to do is this empty string also can be accepted here. So we are starting with one state. you're going to read A and you're going to read B. So it is again coming to an accepting state itself. So the starting and the ending state is going to be the same state itself. Okay, if in case if after A has been read, this state wants to read A, because for B we have already mentioned it has to move on to some other state which is not an accepting state at all. Okay, so it's moving on to some other state. Here this first state has to read only A, it should not read B. So if it is going to read B, it will be moving on to some other state which is not an accepting state. Okay, so in the state also we have A and B, so it has been put in a self loop. So for this you can see empty string obviously it will be starting and ending it in the start state itself. So then you have an AB, so A and B. Then you have AB, AB. So you have A, B and A, B. So like that you can mention all these things. Then you have another thing that is called as A plus A star B. So what can be the possibilities? You can see A, okay, then you have to add this plus, okay, like multiplication you can also have plus also. So A, here it is empty string, that is 0 or more values. Okay, so this A will be taken into account, or it will also have a number of A's. So in that case A, B, so single A, so A, B, then A, B, so A, B, like this it will be forming. So if that is the case, you can see this has been formed. Now you have a start state. We have to read A. Once it reads A also, it has to be in an accepted state, so we have one as an accepted state. Then after reading A, you read another A, okay, and you have n number of A's can be read, so you have a self loop. Then you have a B, it is moving on to the final state. So this whole part alone you have to concentrate. Other parts you have to see what all the input symbols that has been left out. So for this A has been mentioned, so B I am moving on to another state. For this case I am taken A, B has to be moved on, so B also is also a possibility. So A, and you can also have B. Okay, so that also is a possible condition, so that can be mentioned. So all these things has to be taken into account. Okay, these are some of the sample experiments. Already we have discussed all the solutions earlier with the help of a diagram. So please code this in the with the help of Python. Okay, the next one is NFA, or you can call it as NDFA, that is non-deterministic finite automata. Non-deterministic finite automata is also going to have 5 tuples. You have a set of states, you have a set of input symbols, you have a set of transitions, we have a start state, we have an accepting state. Then what will be the difference between deterministic finite automata and non-deterministic finite automata? As I have discussed earlier itself, what is the possibility is, when you're going to read an input symbol, it can move to only one state in the case of deterministic finite automata. But in the case of non-deterministic finite automata, it can read the same input symbol and it can move on to many states. So multiple edges with the same letter can be possible. So and you can also have epsilon edges also. You can remember that. Okay. So in this example, we have taken a very simple example. NFA that recognizes the language of strings that end in 0, 1. So I am taking Q0, it is a start state, it is going to have 0, it's read to 0, it is moving on to Q1, then it is read 1, it is moving on to Q2. Okay, you have to remember one thing, my language should end with 0, 1. Before that I can have n number of possibilities. How much is zeros and ones, whatever is the case, I can take it. So in that case, this Q0, I can accept any number of zeros, any number of ones, or combinations of zeros and ones, anything is possible. But once it has moved on with the last 0, it cannot read anything. So this Q1 is not having a 0 at all. You don't have to put any self loop for 0. Okay, then this q1 also it is reading 1, so it is not having a 0. Then q2, after q2 it's not necessary that you should have a self loop for 0 and 1 because it is a non-deterministic finite automata. So there is a second condition also we have to take it into account. In a non-deterministic finite automata, it is not necessary that each and every symbol has to be read and it has to be moved on to another state. But in the case of deterministic finite automata, for each and every input it has to move on to another state. So in this case we have an input symbol as 0 and 1. For q0 alone we have taken both the input symbol. For the case of q1 we have not taken 0. In the case of q2 we have not taken 0 as well as 1. And you can also see the condition C, q0 is reading 0 and it is moving on to q0 also, as well as it is moving on to q1 also. So it is reading 0, it is moving on to q0 and q1. In the case of deterministic finite automata, it can move only to one state. So this possibility of 0 is not going to appear in the case of deterministic finite automata. So this is the transition diagram. You can see instead of dash I have put it an empty symbol. Same things whatever we have discussed in DFA, same thing is here also. So q0 it is reading 0 and it is moving on to q0 and q1. Okay, and for q1 also it is reading 0. Okay, then for q1 it is going to read 1 and it's moving on to q2, and q2 is not reading any symbol, so we have empty. So how we are going to implement in the case of Python? So in the case of DFA we have mentioned it as DFA. Here it has to be NFA. Sorry, so that has been wrong here. So it is going to be NFA. And the next one is, here also we have NFA. We have to mention all the tuples. So it is going to be the states. We have the input symbols, we have the transitions, we have the initial state, we have the final states. Okay, and we want to check whether that particular input is accepted or not. That also you can see. You want to see the stepwise state transitions, you can do that. Okay, so the example that we have seen earlier, same thing I have taken. I have mentioned the states, I mentioned the input symbols, I have taken the transitions, I have mentioned all the transitions. We have mapped it along with the transition table or from the diagram. Then we have the initial state, we have the final state. So I am just checking whether 0 1 is accepted. It will show me q0 as well as q1. Okay, and I'm just checking 1 1, it will be throwing me an error. Okay, can you understand why it is why it has been 0 1 in this case? Is, you can see in this one it's going to read 0 1, so it will move on to q2 also, and 0 1 it will be moving on to q0 also, which is not an accepting state actually. What is the accepting state? It is q2 is the accepting state. In the case of DFA, if it is moving on to the accepting state alone, you can say that particular string has been accepted. But in this case it is also mentioning q0 along with the input reading. In that case we have to check whether it is containing the accepting state. So in this case we have an accepting state as q2. So if that is the possibility, then you can say like it is an accepting one. So the same for input stepwise also. You can also check whether it is accepting the input also with the help of 0 1. So and you can also validate the particular NFA. So these are the codes that I have already implemented for the particular NFA. So I want to just clarify something in the case of NFA. If it is going to be R plus S, it is going to be R, and you can also have S. If it is going to be R into S, it's going to be R followed by S. If it is going to be as start, remember always I said you have an empty string. In the case of NFA, you have to put an empty followed by an R. Here you have an empty, so this has to be done like this in the case of NFA. So these are some of the exercises. You can try it along with the steps that I have followed, and you can also code it in the case of with the help of Python. Thank you.